So the last type of vector application problem is the work problem, the work done by force. So if you have a force acting on an object to move it from point A to point B, again, F is parallel to AB, then the work, W done by F, is the magnitude of the force times the distance from A to B, or work is equal to the magnitude of the force times AB. So the work is going to be equal to the dot product of the force vector times AB. So here's some illustrations of what we're going to be doing. So to calculate the work done by the constant force F in any direction to move an object from point A to point B, you can use vector projection of F onto B. Therefore, work can be calculated by finding the dot product of the constant force and the directed distance. So that's what we're going to be finding, the dot product. So here's an example. Before we talk about that, when we talk about work, there's certain units for work that we will be using. We've got foot-pound, which is a customary unit of measure. It could be measured in Newton meters, or joules, which is part of the metric system. So to calculate work, a person is pushing a car with a constant force of 120 newtons at a constant angle of 45 degrees as shown. Find the work done in joules moving the car 10 meters. So again, we're moving the car with a constant force of 120 newtons. So again, that's your force. Again, when we're pushing it, constant force of 120 newtons. So that's my magnitude. And again, the angle that this vector is forming with the horizontal is 45 degrees. So again, what I can do is I can find my vector by taking the magnitude, multiplying it by the cosine of 45 degrees, 120 times the sine of 45 degrees. And again, I'm moving this object 10 meters. I'm pushing it 10 meters. So this horizontal vector, which I'm going to find the dot product for, is going to be 10, 0. So again, I can take 120 times the cosine of 45, which is 84.853. I don't really need to find this one, because it's going to be multiplied by 0 with the dot product, but that's also 84.853. And I'm going to find the dot product of 10, 0. So I end up with 848.528 newtons. So the work done in, it's done in joules, excuse me, done in joules would be 848.528. So I found the horizontal and vertical component of my force vector, multiplied it, find the dot product with the distance that it's traveling. So here's another example. You have Rick is pushing a vacuum cleaner with a force of 85 pounds. The handle of the vacuum makes 60 degrees with the floor. How much work in foot-pounds does he do if he has pushed the vacuum cleaner 6 feet? So again, I can find my force vector by taking the magnitude, multiplying it by the cosine of 60 degrees, and 85 times the sine of 60 degrees. I'm going to find the dot product of how far I'm pushing the vacuum cleaner, which is 6 feet, which is 6, 0, because I'm pushing it 6 meters. So 85 times the cosine of 60 is 42.5. 85 times the sine of 60 is 73.612. And again, I'm going to multiply that or find the dot product with the 60 vector. So 42.5 times 6 is equal to 255 foot-pounds. So we have a wagon, last example. A wagon is pulled horizontally by exerting a force of 25 pounds on the handle at an angle of 30 degrees with the horizontal. How much work is being done in moving the wagon 50 feet? So again, the force on the handle is 25 pounds, and it's forming 30 degrees with the horizontal. So again, I know the magnitude of this vector is 25, and again, I want to find how much work is going to be done to move this wagon 50 feet. So I'm going to use the dot product. I'm going to take the force vector, which I can find to be 25 cosine of 30 degrees, 25 sine of 30 degrees. Find the dot product with that with a horizontal vector of 50, 0. So 25 times the cosine of 30, which is 21.651. 25 times the sine of 30, which is 12.5. And again, I'm going to multiply that by the horizontal vector of 50, 0. So I'm going to find the dot product. So 21.651 times 50, which gives me 1,082.55. And since there's no units given, we're going to just use the customary unit of foot-pounds. So that is your workforce problem.